Welcome to the Decarb Connect podcast. And this week we are carrying on with our December theme of disruption and innovation that's sort of helping really push forward industrial decarbonisation with a conversation with Ben Turner, who is CEO of Origen. And Ben, I'm going to hand to you at this point to really sort of give us a little sense of you, but also Origen and Origen's work in the lime industry, and how have you come to this point in time where you are driving a zero carbon lime production and the plans that you have unfolding?
Yeah, thanks a lot, Alex, and hello, everybody. So that is very much a two-part question, actually. From an Origen perspective, this business started kind of the back end or early stage of the 2010s, actually, with a gentleman called Tim Kruger, who runs Oxford University's carbon dioxide removal initiative, becoming very interested in the use of zero carbon lime as a mechanism for the purposes of CO2 capture and indeed CO2 removal. So over the past decade or so, Origen really has been working on all of those constituent components to allow us to do that. From my perspective, I'm a climate scientist and geologist from an academic perspective, so I've always had a huge interest in everything to do with climate. But I actually spent best part of the past decade working in finance, where I was involved in making investments across a whole host of different industries, but in particular having a focus on renewables and the carbon markets. And about 3-4 years or so ago, I kind of started asking myself the question, why are you making investments when you could actually be at grassroots level making this happen? And so I remember reading the IPCC report of 2018, and I just said to myself, Ben, you've got to leave and you've got to find yourself a great industry to get involved in, or a great company, sorry. So I actually spent 6 months traveling around Europe, met a whole host of carbon dioxide removal companies, decarbonisation companies, happened across Origen in early 2019. And the rest is history, really, Alex.
And the focus on the lime sector, I mean, clearly that's not what you're rooted in, but I mean, actually probably puts you in a perfect position to sort of just give a layman's overview of that sector to people, because I think it's one of those industries that's kind of invisible. Just give us a bit of a kind of a flavor of the lime industry and some of those key stats about, you know, how is it that they fit in this kind of hard to abate grouping of companies and organizations. Give us a bit of a flavor of that sector.
Lime is, as you said, one of those relatively unknown industries. But actually, when you start unpacking it, you start realizing it's a massively vital industry. And lime is used in a whole host of end goods or products that touch our everyday lives. So lime is used in steel manufacturing. Lime is used, you mentioned, in cement, but it's also used in other building materials. But maybe from a day-to-day layperson's perspective, it's used in the manufacturing of sugar. So all that sugar we consume has used lime for the purification process. The same goes for water, and the same goes for some other day-to-day consumables that people use every day. So I think that when you start understanding how many parts of our lives it touches, you start realizing how important this is as a commodity. Now, this is a really big industry globally. About 400 million tons of lime are produced each year. And with that, about 400 million tons of carbon dioxide are emitted. And as you identified, lime is termed a hard to abate industry, and it's hard to abate for two key reasons. The first is, in order to calcine limestone, which is where you break down limestone to form lime, you need to produce temperatures of about 1,000 degrees centigrade. That means you need to burn a lot. And the combustion of those fuels results in carbon dioxide emissions. In addition to that, when you are breaking down limestone, thermally degrading it in that calcination process, you have irreducible carbon dioxide emissions. Limestone is known as calcium carbonate chemically, and it breaks down into lime, calcium oxide, and CO2 carbon dioxide. And when you look at that breakdown of the ton of CO2 produced about 65 to 70% of it actually comes from the limestone breaking down itself, and the balance comes from the combustion of the process. So it's extremely hard to avoid those irreducible emissions, but you also need the temperatures from burning fuels.
One of the interesting things that we'll be exploring a little is this lime post-process is not just used in all those other sectors you talked about, but also has this capability of actually reabsorbing CO2 and is therefore potential product or tool or technique, or however you describe it, for carbon capture or carbon recapture, perhaps is the phraseology for it. Let's have a look then at sort of some of the opportunities for CO2 reduction around this sector then, and we will obviously come to Origen's specific role in this, but tell us a bit about, what is it that, what are the opportunities for CO2 reduction in this sector, both in the US and the UK, because of course that's also another interesting part of your company experience, is that you are operating in both markets. So tell us a bit about that.
Yeah, absolutely. So because of that carbon intensity, and certainly in Europe because of the carbon price, there is a real push to do something about those hard to abate emissions from this industry at this moment in time. Now, the European Emissions Trading Scheme, EU ETS, grants quite a lot of free credits to this industry because of its carbon intensity. And as such, the industry is not fully absorbing the full impact of all of those emissions at this moment in time. But those free credits are being scaled back. And what that means is that carbon intensity ultimately results in quite a marked financial impact for this industry. And if we use some really high level numbers here, if every ton of lime produced results in approximately a 30 to 35 euro per ton profit margin for that industry. And if we put last week's highs of the carbon price in Europe of about 70 to 75 euros, I think it was, you can very quickly see how this industry goes from being nicely profitable to significantly loss-making. And so that's one of the major issues that this industry, and it's not this industry alone, but any heavy industry really faces. Out in the US, it's a slightly different equation. In the US, there is no carbon price. There are suggestions there might be a carbon price, and I think the direction of travel is probably that way, although the time frame for that, I'm not entirely sure. But out in the US, there exists a tax credit, and it's called 45Q, which pays you to store carbon dioxide. And what we have been working with the lime industry in the US on is, can we monetize that tax credit such that we cover all of the costs of utilizing a technology like ours to capture the CO2, and then the processes required for the compression, transport, and storage. So that kind of gives you that overarching picture. Ultimately, in a couple of words, it's cost of carbon impacting financial sustainability. And that's what we're trying to mitigate here.
And then in terms of, so you've mentioned the actual kind of opportunities for the capture, which is the technology of yours that we'll be talking about. I kind of reconnected with you, actually, having connected earlier in the year because of Scott Rennie, your partner at Volt in the US. So just give us, again, a bit of a sense of Volt, that partnership. What does it mean?
One of the biggest issues is it's all well and good capturing carbon dioxide, but unless you can do something with it, either store it or use it productively, you might as well have not captured that CO2 because you're not doing anything with it otherwise. And so Volt, through Scott, are working on the storage side of things there. Now, Volt are a business a couple of years old now, based out in Calgary. Scott has a background in the oil and gas industry, in particular, though, a focus on CO2 storage implementation and CO2 storage solutions. So he and many of his team members have been involved with a huge number of the carbon capture and storage projects on the North American continent. So for us, they're a fantastic partner here, helping us navigate the regulatory environment, the technical environment, the stakeholder management environment. And really from an Origen perspective, what this has meant is we can approach the lime industry with an integrated capture and storage solution, i.e., we can talk to them about Origen's technology for the purposes of avoiding emissions, but we have a solution in place, or that can be developed for the purposes of storing that carbon dioxide. And so that kind of symbiotic relationship where each of us, Volt and Origen, take care of different parts of that value chain is proving really important here.
Again, I know I keep saying we're going to talk about your technology. We are going to talk about your technology, but just one more question on the storage piece, because something that comes up quite often actually in conversation with some of the industrials that we're connected to is this kind of growing sense that, okay, it's great that there are some emerging opportunities for both capture and storage, but what's that middle piece? So I'm just wondering, where are the opportunities, where are the challenges there for you and Volton? I mean, what kind of CO2 transport really needs to emerge to help me deliver on the promise of the original technology?
Yeah, that's a really good question, actually. And you can answer that in different ways. So one of the big pieces of work that we've done with Volt in North America is to map the lime facilities and their locations. And we've overlaid a geological map on top of that. So we're able to really identify the kind of 4, 5, 6 key emission areas and where CO2 storage in close proximity to each of those facilities exists. And the reason why proximity to storage facilities is important is because the transport component has quite a market cost as we get longer and longer in terms of pipeline. And so what we're able to do is identify really 3 key locations where storage is really close to the source of those emissions, which actually means the transport cost is a lot lower than it would otherwise need to be. In other instances, and this is really the case in Europe, where we're doing a lot of storage or intend to do a lot of storage in the North Sea, we need a huge infrastructure rollout to carry all of that carbon dioxide from the point source emissions, often in the middle of Europe, to the North Sea. The same is true in part for the US. I think everybody recognizes that. Certainly the Biden infrastructure plan is plowing a lot of capital into the development of this type of infrastructure solution. And I think it's very obvious just from all the press that we're seeing around projects like Northern Lights, the East Coast Cluster, HyNet, Port of Rotterdam, et cetera, there's the kind of same weight of capital flowing into Europe and those solutions as well. It takes time. These projects need permitting. They need to be cleared with multiple stakeholders, but the direction of travel is there. We've started, and I think making a start is probably the most important aspect of this journey.
Okay, well, let's kind of now step back into Origen. So we're going to sort of talk a little bit about the nature of the conversation that you guys have with lime producers, but before we do, just give that overview. Like, what is it that the Origen technology does and allows?
At its core, Origen's technology ultimately allows the production of zero carbon lime. That is lime without the associated carbon dioxide emissions. So we are capturing 100% of the CO2 emissions from the lime manufacturing process that can then be compressed, transported, and stored. That's the key to what Origen's doing.
So when you talk with lime producers, tell me a bit about how does that conversation go? Is there much of, do they need to be sold on the technology? Do they need to be sold on the why they should do it? Or what comes up when you bring this to their front door?
Yeah, I think we approach it from 2 perspectives. The first is the sustainability perspective, and sustainability is both financial and environmental. This industry is an old industry. It's been around for a very long period of time, and a lot of these businesses are actually family owned. They have a real sustainability conscience, and they are focused on addressing some of the issues, all the issues that are just part and parcel of producing lime. So once we start breaking down that kind of economic value stack, revenues minus costs driving profits, and we start understanding how carbon prices impact that profit line, how the implementation or the use of carbon capture technologies implement that profit line, we start getting into a really good 2-way conversation. And then what we can start doing is overlaying things like this 45Q tax credit in the US, where we can recoup some of the costs that are used or introduced as a function, of using that type of technology. And that normally results in a really proactive conversation. This industry is really aware of the problem, in inverted commas, that is facing it. So it's not that difficult to sell them on that. The second angle that we come at it from is really what can zero carbon lime be used for in terms of maintaining the status quo, but also future upside opportunities. So it can obviously be used for maintaining the status quo, servicing existing end markets. But the whole purpose of decarbonizing lime here, from an origin perspective anyway, is to use that decarbonized lime or zero carbon lime to remove CO2 from flue gases and indeed remove CO2 from the air itself. And selling them on that big picture kind of opens up new opportunities for them, commercial opportunities that are probably way larger than the existing end markets that they're currently serving. And so coming at it from a kind of collaborative, we can help you solve a problem, we can boost your economics, and we believe it opens up a much larger business opportunity further down the line, has resulted in some really encouraging engagement.
The unexplored opportunity that they have ahead of them to reabsorb CO2 in different applications. Tell us a bit about that market. Like, what else do you see there, and why is that such a big opportunity for them?
What is ultimately at play here is what's called the lime cycle. So we've got a reversible reaction between limestone, calcium carbonate, and lime, calcium oxide. And as I said a little bit earlier, if you heat up limestone to 950 degrees Celsius, it thermally degrades into CO2 and lime. That lime has a natural affinity for carbon dioxide. It will react preferentially with that carbon dioxide to reform a more stable compound, calcium carbonate. And that's ultimately what Origen is playing with here. What are we doing in terms of developmental work here? So at Heriot-Watt University, we have a carbon capture demonstration rig, and that rig there is basically got a bed of lime, and we are passing varying concentrations of carbon dioxide through that bed of lime to better understand the reaction kinetics. And the reaction kinetics are key here because they help us understand the optimal conditions for the purposes of capturing CO2. And obviously through Decarb Connect, you see a huge amount of industries here who are looking at lots and lots of different solutions that they need to be able to capture carbon dioxide off the back end of their stacks. And this route that I'm talking about here is one potential route. What it does mean is if we're capturing carbon dioxide in the form of a carbonate material, it means we've got a solids handling issue rather than the carbon dioxide transport issue across the continent. And so we've been looking at things like that. We've got a project at this moment in time with Tate & Lyle Sugars in London, looking at utilizing this type of technology. And in several of our conversations out in North America, we've been exploring this in a lot more detail as well.
I'm going to ask you the question that I'm also sure is on the lips of any lime producer, which is give me an overview of what this is going to cost me. So what's the additional premium at the moment for producing using your technology to produce this zero carbon lime per ton?
Yeah, that is a very pertinent question, a very important question. So using Origen's process, we calculate our incremental cost for the purposes of capture at anywhere between $7 per ton of CO2 and $25 per ton of CO2. Now, the reason for that range is it depends what you are comparing your technology or our technology to. A more heavy emitting, less efficient process, we're going to have a cheaper cost. A more efficient process, we're going to be slightly more expensive. And then on top of that, we have got the other costs associated with compression, transport, and storage. And what's really important to understand here is they're not small costs. In the context of the capital stack required for CCUS, we are about at the low end 10%, and at the upper end maybe 25%, so $10 to $25 per ton, as I was kind of alluding to. Compression is expensive. It's energy intensive. It's $20 to $25 per ton. Transport can go from zero, harking back to on-site storage, to upwards of $20, $25 per ton, depending on the distance. And then from a storage perspective, really the reservoir dynamics determine that. And they can be anywhere from maybe $5 per ton in a perfect location, all the way up to $25 per ton. So there is a cost to this, depending on the location geographically, whether or not it's Europe or the US, and depending on the different credits, ultimately determines whether or not you've got an incremental cost here or your costs are covered as a function of those credits. Does that make sense?
Yeah, I think it does. I think it's kind of always interesting the different types of influences on the idea of a premium around any technology like this, that it's so dependent on the geography because of that trading environment. It's the geography dependent on that, literally the geology of the environment. But yeah, that makes sense. Thanks.
I think one point I would just make perhaps as well is, we've modeled quite conservatively. I prefer not to get aggressive with modeling at this moment in time, at least not until we've got more clarity on the kind of end-to-end economics. But for us, we don't really envisage having to sell this lime at a premium to make it economically viable, which therefore means the lime industry has an opportunity to decarbonize without necessarily having an incremental cost. Now, the incremental cost obviously comes, there is incremental cost, but it's recouped through that tax credit in the US. And I think we're starting to get to a point now in Europe where, relative to the carbon price, our technology is cost comparable. And what that means is we can capture and ultimately store CO2 for less than that carbon price, which is really an important inflection point here, because there is then an economic incentive to no longer pay that carbon price, but actually do something from an abatement perspective.
The last question in this stage of our conversation, because part 2 of our recording will focus more on an example of an active project that you are about to break ground on in the UK. But for the purpose of this part 1, I guess the question is, where are you at the moment? What stage of development and in finance are you as Origen in?
From a kind of a business perspective, you've just kind of given a little bit away in your introduction there. So we just broke ground on a pilot project at the beginning of November. That should be built by April kind of time next year, let's say Q2 2022. We're moving to commissioning, and then we're moving into kind of commercial optimizations through Q3 and Q4 2022. So that really is a combination of proof of concept, i.e. we're shown we can produce zero carbon lime. It's also then going to be really leveraging the feedback that we are getting from the industry to drive optimizations of that technology to help inform the scaling of that technology for the purposes of commercial deployment. So that's kind of at the crux of, let's say, the commercial engagement and the technical de-risking. Commercially itself, we have been speaking to all of the major lime manufacturers, both in Europe and in North America. And then from I guess, a financing perspective, so we're still a small, young organization at the end of the day. We're about 15 people. We have been very successful in securing UK government grant funding for various aspects of the early development. We've also been successful in securing equity funding from private investors. So we're going to be moving towards a fresh raise early-ish next year, with the views to doing kind of a Series A, maybe 10 to 15 million pounds or so in Q3 or Q4 next year, so 2022.
And the other thing that struck me when you and I spoke ahead of this was you've also kind of been able to secure some really interesting people into Origen. It's kind of already got some pretty heavy hitting industry folk there.
Absolutely. We have been really fortunate to secure some extremely talented individuals. So if I just go back to some of the original kind of people involved in this venture, really important to point to a gentleman called Barry Jenkins, who really is our engineering brains. Barry's got 40 plus years worth of experience in combustion engineering as well as kiln technologies. And I guess this could be described as his baby or his original design. But going on from that, we've just made some fantastic hires over the course of the past couple of months or so. We just hired a gentleman called Chris Hankinson, who used to be head of engineering at Rolls-Royce. He used to run their nuclear, civil nuclear division. We've hired a gentleman called Dustin Poole out in the US. Dustin used to be part of the portfolio strategy team at Hess Corp, recognizing that the direction of travel was renewables, jumped kind of over to our side, or energy transition, sorry, jumped over to our side. And then the rest of the team has just been incredible as well. We've got some fantastic young engineers coming out of 5-8 years worth of experience in industry, recognizing the direction of travel, and utilizing some really valuable skills, repurposing them to really drive our business forward as well. So it's really exciting. The people side is probably the most exciting part for me, certainly recently anyway.
Yeah, I can see that. Obviously, this is an audio environment, so the audience can't, but you really light up when you talk about the co-workers and people that you're bringing into the team. Well, look, we're gonna pause this conversation here, and then in part 2, which our listeners will hear next week, we'll focus in a little more on the UK project, Singleton Birch Plant, and we'll kind of explore what that means and how it came about. So many thanks, Ben, and I'll look forward to part 2.
Absolutely. Thanks a lot, Alex.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.